Hi, I'm David Bolton of Go Parallel, and today I'm going to talk about a programming language that you rarely hear about. It's FORTRAN. Yes, that FORTRAN, a language that will soon be 60 years old in a couple of years. FORTRAN is still highly popular in the numeric and scientific communities, and there's at least one free FORTRAN compiler, as well as several commercial ones including Intel's, Hewlett-Packard's, PGI, Craze, Oracle and a couple of others. FORTRAN has grown through 10 different versions, though the last one's still too recent to be much more than a specification. That's 2015. So what has changed? Well, the version I learned was FORTRAN 4, but really the modern stuff starts back with FORTRAN 90 that was released in 1991. Perhaps the most significant change was free-form source. No longer did you have to put comments in the first 6 columns and then code from column 7 onwards. That's a relic of the days of punch cards, and most of those were phased out at the start of the 1980s. Add to that modules and dynamic memory allocation. Significantly, much of the language's syntax was cleaned up in FORTRAN 95 with what you call dodgy features like assigned goto, non-integer loops, branching to an end if from outside its block, and pause statements, and these were all removed. To be fair to FORTRAN, it was the first high-level programming language appearing 2 years before COBOL. Much of what we know about computer science came after that, and new releases of FORTRAN have adopted these practices. FORTRAN 2003 added support for object-oriented programming and lots more, including interoperability with C, and floating point arithmetic used the IEEE 754 standard. Finally, the FORTRAN 2008 standard improved interoperability with C even more and introduced co-array FORTRAN for parallel execution. That said, OpenMP has been available since FORTRAN 95. The next release of FORTRAN will be FORTRAN 2015, though it's not expected until 2018. Compiler support for FORTRAN 2008 is not complete. If we look at the FORTRAN wiki here, it shows us probably as many reds as there are greens, and that goes all the way down there. Even FORTRAN 2003 support is only complete in compilers by Intel, Cray and IBM. It's probably why even FORTRAN 90 and FORTRAN 77 are still so popular on the web. If we look at Google Trends here, you can see I'm comparing FORTRAN 77, 90, 95, and that's 2003, not 20. I wanted to show you that FORTRAN isn't just always for numeric processing, although I don't think it'll ever take over in the games industry. What I've got here is a video poker game. It's included with the Intel compiler, and it's made up of 9 source code files and a few graphics. And what I'll do is I'll build this so you can see how long it takes to compile. So it's a few seconds. And then link. And we're ready to go. Let me just run this. Now, I'm not very good at playing poker, as anybody who's ever played me will know. And nothing there. I'll hold the king and the jack, and I lost. Great, have another go. So, yeah, nothing worth holding. Oh, almost had a straight. One last time, and just hold those two, and nope, nothing at all. Unlike C# or VB.NET, the visual design is on a par with Visual C++, where you have to do a lot of the graphics and mapping. That's all the code that's needed for things like pressing a button. It's a quick windowing system. It's not really intended for overly complex GUIs. Provided with Intel compiler are some more samples for more traditional window GUIs, and they're under the dialog examples, and they provide a better idea of what it's like to code. And it's like Visual C++, where you have to join everything and do everything. There's no graphical thing. But if you just take a quick look at this, and you can see it's just a standard Windows form, a bit old-fashioned in these days of WPF, but it's all there, all the different standard Windows form controls. So you can do that in FORTRAN as well. So if you're coming back to FORTRAN or considering learning it, what are the most important new features that you should be considering? Plus, which version should you start with? If C compatibility is not that important, then I recommend FORTRAN 95. You get dynamic arrays that can be resized at runtime using allocate and deallocate keywords. FORTRAN is particularly strong with arrays. To see how powerful and fast FORTRAN arrays can be, I've cobbled together a program that sets a 1,000,000 element float array to a value of 0.5, then it gets the cosine of each element into a second array. It then subtracts the 2 array elements, and that's in just one simple statement, and then does various other intensive computations including matrix multiply, dot product, square root and exponentiation, and the whole thing takes under 1/6 of a second. I'll just run this so you can see it. It's that quick. Just for fun, I thought I'd test another FORTRAN program to see just how fast it could run using the Intel 16 compiler on my 6-core CPU. I used the sieve of Eratosthenes, which is a nice integer array algorithm, and timed it. For primes up to a million, it was very fast, well under a second, so I cranked up the stack space to max and set it running. 6 seconds later, it reported there were 12,125,540 prime numbers, less than 220 million. Stack space more or less topped out at that. It's probably not going to compete with the Great Internet Mersenne prime search, but it shows you how fast it can run and the power of FORTRAN's array operations, especially the slicing. The line after the if statement in the do loop, there's the do loop, there's the if one. This one here is a really powerful statement. It sets all elements when it's 2, from 2, 4, 6, 8 up to 220 million. It sets all those to 0. Then it does the next for 3, so 3, 6, 9, 12, and it sets each element to those. It doesn't do 4s because it's already cleared that, so it goes on to 5, so it'll be then 5, 10, 15, 20, and then so it won't do 6 because that's already been cleared, so it does 7, 14, 21, and it won't do 21 because that's been done by 3, but it does that all the way through, and that's why it's so quick. And if you don't believe me, let's just quickly run this, and I'm going to have to hang around for about 5 seconds, 5 or 6 seconds while it's churning away. But and there it is, 6.5 seconds in that case, and there's just 12,122,544. I tried running the program with parallelization turned on, but that blew the stack. So I then tried it with 22 million numbers, or a tenth of the 220, and with parallelization it took 0.548 seconds, but when I turned it off it was quicker at 0.506, so this probably isn't an algorithm that lends itself to being parallelized. There's a lot to be said for FORTRAN when it comes to numeric and scientific programming with arrays. Thank you for watching this video. I'm David Bolton of Go Parallel.